Hello everyone, today we're going to look at angles. So an angle is a mathematical object generated by rotating a ray. So remember, a ray is like half of a line. It has a starting point, and that's called the vertex. So what we do is we take this ray, or half a line, and we rotate it about its fixed point, the vertex, from an initial position, so I'll put I for initial, to a terminal position. So I rotate it to my terminal position. The angle is the amount of rotation, so how much I moved it. The angle is positive if the rotation is counterclockwise, and it's negative if it's clockwise. So it's a little counterintuitive. The clock is actually showing out negative angles. We usually use Greek letters to denote the angles. So we have alpha, beta, theta, and phi or phi, depending on who you talk to. So you'll see these letters come up a lot. And then angles are measured in degrees and radians. For now, we're going to focus on degrees, but as we get further into these sections, we're going to talk about radians at the end. Okay, so for now, make sure your calculator is in degree mode. Two angles are called coterminal if they share the same initial and terminal sides. So pictorially, it would look something like this. Here is my angle, my initial side. Here's my terminal side. I can have this angle. I'll call it alpha. I could have, so notice that alpha is a positive angle. I could have the negative angle. I'll call it beta. I could also go, starting from my initial, go around a full circle, and then go to my terminal side. I'll call that theta. I could also go backwards a whole circle, and then go to my terminal side. And I'll call that one phi. So those are 4 examples of angles that are all coterminal with each other. They start at the same spot, they end at the same spot, but how they moved is different. And I could keep going a circle after circle after circle after circle, and as long as I eventually stop at my terminal side, that will be coterminal. So that's what it looks like pictorially. The question is, how do we determine it mathematically? So we have the equation alpha equals beta plus k times 360. And as long as k is an integer, then alpha and beta are coterminal. So as long as they are off by some number of circles, right? There are 360 degrees in a full circle. So you might have questions like, find 2 angles, say, one positive, one negative, that are coterminal to 85 degrees. So I'm going to put 85 into beta because I'm looking for an angle, so I'm going to be looking for alpha. So alpha equals 85 plus, and then I can choose any integer that I want to make 85 plus k times 360 positive if I'm looking at the positive one first. I'll go back to red. So I'm just going to choose 1. It's a really nice integer, and I know that 85 plus 360 will be a positive number. And I get 445 degrees. So 85 degrees, 445 degrees, those are coterminal. If I start them at the same spot, they're going to end at the same spot. Another k that I can take is, say, negative 3. Again, any integer will work as long as what I get out is negative. I could have done negative 1, negative 2, negative 2500, right? So I'm just choosing something that's not 1 at the moment. So negative 3. I get negative 1072. Okay, so again, this is coterminal with 85. It's going in the opposite direction, and it's going 3 extra circles. What we're going to really focus on right now, though, is what's called standard position. We're going to use this quite a bit in the coming sections. So generally, we don't want our angles just floating in space. It's not very helpful. So what we do is we standardize their position by placing it on the Cartesian plane, and we do so such that its initial side is the positive x-axis and it's rotated along the origin. So its vertex is the origin. So here is the Cartesian plane. So again, the positive x-axis is always going to be my initial side, so that if my terminal side were also the positive x-axis, I would have a 0-degree angle. And as I rotate in the counterclockwise position, so a positive angle, if I stop at the y-axis, I've gone 90 degrees. So remember, a whole circle is 360, so a quarter of it is 90. And then I go another quarter of a circle to the negative x-axis, and I'm at 180 degrees. Then I go another quarter to the negative y-axis, and I'm at 270. And then I keep going, and I end up at 360 because I've got a whole circle. And I could keep going, right? 2 full circles would be 720 degrees. I could keep going as much as I want. We can also, again, go backwards. So if I wanted to, again, start at my initial position, the positive x-axis, I could go clockwise. If I go clockwise a quarter of a circle, I've gone my negative 90 down here. And then another quarter of a circle, in the backwards or clockwise rotation, I'm at negative 180. Another quarter, negative 270. Another quarter, that's negative a circle, so negative 360. Okay? So just remember, every quarter is 90 degrees because a quarter of 360 is 90. So we've got 0, 90, 180, 270, 360, and the negatives if we go backwards or clockwise. So we're going to do some examples of just drawing some angles. So draw the following angles. We've got A, which is 40 degrees. So I'm going to do A in blue. So 40 is almost halfway between 0 and 90, right? 45 would be halfway between. So my angle of 40 is going to be a little bit less than halfway. That's probably closer to 45. But anyway, make sure you put an arrow indicating which way you're going, because again, if I just draw the ray arrow, there are an infinite number of angles that does that. So I need to draw in my little directional arrow there to tell me I'm actually doing the smaller positive angle, the 40 degrees. So next we're going to do 200. So 200 is positive, right? And again, half a circle is 180 degrees. 3/4 is 270, so it's somewhere between 180 and 270. It's somewhere in quadrant 3. 200 is a lot closer to the x-axis than the y-axis, to 180 than to 270. So it's going to be somewhere around here. And again, I'm going to draw the arrow to indicate that it is the 200 degrees and not any other coterminal angle. I'm going to do C in green. So negative 100 degrees. So remember, negative means I'm going clockwise. And as soon as I get to my negative y-axis, I've gone negative 90. And I need to go a little bit more. So I need to get to negative 100. So it's going to be something close to this. You don't have to be exact. I'm not expecting you to take out a protractor or anything. Okay, so again, I'm going to take my denote my arrow, saying it is the clockwise negative angle that we're looking at. And then the last one I'm going to do in black because that yellow is kind of hard to see. So 310 degrees, it's positive. So I'm going counterclockwise, going through the quadrants in order, right? Quadrant 1, quadrant 2, quadrant 3, quadrant 4. 310 is between 270 and 360, so it is a quadrant 4 angle. And it's, again, close to halfway. 315, I believe, would be halfway. So it's a little bit less than half. So right around here. And again, I need to indicate that I'm doing the positive version of that angle. Okay. So don't forget, whenever you're drawing angles with certain degrees, make sure you do put that rotational arrow symbol so I know which way your angle is actually going. Okay, so just read through this. Let me know if you have any questions, and good luck.